In this video, we will examine the surface area of prisms. And as a reminder, a prism is a polyhedron with two congruent bases, and those are in parallel planes, parallel to each other. And then the lateral sides are all made up of rectangles. So in our first one here, we have a triangular prism, and the congruent bases are the bases, the triangular sides that are parallel to each other on the two ends of that. And as you've seen from previous videos, we can unwrap this to make a net, and then you can use that net to find the total surface area, or in other words, the outside wrapping of that. So just be a matter of finding the areas of these shapes. Individually, all we have here are rectangles and triangles. So this rectangle here would be 28 by 7. 28 times 7 will give you the area of that. This rectangular here will be 24 by 28. The one next to it will be 25 by 28. And then the two triangles, the bases are actually congruent. They're 7 by 24, each one of them. Remember, the area formula for a triangle is 1/2 base times height. And so we'll have that twice. Now, if you would just take all of those numbers, multiply them all out, add them all together, you can find the total surface area. I'm going to leave that as a numerical exercise for you right now. Okay, now that you've done that, let's continue. Let's look at this rectangular prism here. A rectangular prism can be viewed any way to have parallel bases because there's 3 sets. Probably the most common is to look at the one that we think of as being oriented downwards. So there's that base and that base. And if you unwrapped it, you would have that large base, right? You'd have the smaller flaps on the sides that you could draw out. I don't have dimensions on this particular problem. You have the other flaps that come down. And then the other large base, the congruent base, is the top. You can put it either up here or down here. It really doesn't matter where you draw it, so long as that you draw it. So I'm not going to look at a specific numerical example, but just be thinking about how it's made up of rectangles. Okay, notice that this is also a prism. This is called a pentagonal prism. And pentagonal prisms have also the same idea in terms of they have parallel bases. In this case, the bases that are parallel are pentagons themselves. Now, those are going to be really hard to redraw into a net. Find it challenging to draw a pentagon. But notice that the other sides are made up of rectangles, right? We have these rectangular sides here. And in this case, if this is a regular pentagon, this is trying to be a picture of one, then those are actually 5. I didn't highlight them all, but let me highlight the other ones. There's one there, one along the back. There's 5 congruent rectangles. So you have, these rectangles that can extend out from the bottom if you were to unfold this. And individually, those areas would be very easy to find. For example, if the length along one of the rectangles was 5, and maybe the height of this pentagonal prism was 7, then each one of these rectangles would just be 5 times 7, or 35 square units. You would have that in each one of these. The more challenging piece, of course, would be to find out, what is the area of the base itself. And then remember, we have a top, so you can draw that somewhere connected to it. 1, 2, 3, 4, 5. You can see that's kind of ugly. That's not a very good pentagon. And you would have that area as well. So in other words, it's made up of congruent bases and then rectangular sides. It's true for this prism as well. I'm not going to draw the net, but notice that the bases are octagons. This is an octagonal prism. So again, it would be 2 octagons, and this time it would be 8 of these congruent rectangles if this were a regular pentagon, octagon. Last shape that I want to show you. This is sometimes, some authors would call this not a prism. Some of them would call this a prism. It's because it has a curved side. Now, what I have here is I have a picture on the left of what I'm going to call a prism. I'm going to tell you what kind of prism it is because it has an obscure base shape. But you can see from the top that the shape seems to be somewhat rectangular and somewhat curved. Now, you can't see it, see this because it's not opaque, but there would be the base down below that would be identical. So those would be the 2 congruent bases. Now here I have a picture of the base. Now that we can find the area of pretty simply just by thinking about splitting it up. If we were to draw a line right here, we could imagine that looks like a rectangle 6 by 5. So we could say this one has an area of 30. This looks like a semicircle, and the area of a circle, remember, is pi r squared. The radius looks like 3, but it looks to be half of a circle, so we'd multiply that by a half. So the total area, total surface area of that shape, of that base, would be 30 plus 1/2 pi r squared. Now, I'm just going to estimate this a little bit. I'm going to use 3.14 as pi. I know that's just an estimate. And I get this to be about 14.13 here. Adding that to 30, we get 44.13. That would just be the area of one of the bases. I'm just going to highlight this top base right there. The bottom base also has the same area. So we're going to have two of those. So our total surface area will have 44.13 twice. Now, let's talk about what we're going to call the lateral surface area. Lateral meaning the space around. Now, notice that this time it doesn't look entirely like rectangles. We do see a rectangle. Let me use a different color. We see a rectangle on the end here, but the other space seems to be curved. Now, what you have to do, though, is imagine that this was unwrapped. What would happen if it was unwrapped? We'd have this base that we've already kind of drawn. It looks like this, right? And then certainly this flap that I've colored purple would flip out, and you could get that purple flap there. Now, the other space, though, it's imagine it as a rectangular band that kind of extends around to the outside. It's rectangular shape, but it's curved. But when you unfolded it, it would look like a rectangle, a rather long rectangle, long and skinny. And so it's really, really kind of hard to draw exactly, but maybe it goes way down there, right? And then you have another one of these bases here on the top. But let's look at this long, skinny rectangular piece. So what that would be is let's see if I can highlight it, draw it here with the purple. You have this height here that's the same. And then you have this band here that goes around all the way around to the other side. That would be its length and its width. Well, I need to give you some numbers. So let's just pick a number. Let's say that the height of this figure is 8. Then that rectangle, that purple rectangle here would be 8 by 6. It doesn't, I can see it doesn't look like scaled correctly. And this long rectangle that goes around the outside would be found by figuring out the distance all the way around this figure. Now that would be a little challenging to do because it's made up of 3 parts. There's a length of 5, and a length of 5. So that would be 2 pieces of this. And we'd have a 5 and a 5. But then there's that middle part, the curved part that goes around here. That's actually a semicircle. And so we would have to think of the circumference of a circle, pi times the diameter. Now, since the radius is 3, the diameter is 6, but it's only half of a circle, a semicircle. So we would divide that by 2. So it would be pi times 6 divided by 2. I'm going to estimate that as 9.42. That would be this distance here. So this total length here would be 9.42 plus 5 plus 5, or all the way from top to bottom, 19.42. Then we could have all of the areas. So let's look at them. The area of this rectangular piece is nothing more than 6 times 8, 48. This long rectangular piece is 8 by 19.42, which is 155.36. So my total surface area can still be found just by taking the sum of all of those. 155.36 plus 48 plus 44.13 plus 44.13, and that would be 291.62 square units. All right, hope that gives you a little bit of understanding of a more complex looking prism as well.